Hey Karthi.
Hey Nithilan, how are you?
I'm doing good. Now,
The input to this weather simulation is a lot of things. You get a lot of satellite data. You have a
uh,
lot of observatory towers from which you get a lot of data. Okay, va? So input data across the world, lot of satellites are there, lot of observation towers are there, lot of simple monitoring stations are there. They send a lot of input data. These are baseline data. These are real
so
data.
so so they don't like it's not like only all will be images or it's like a multimodality மாதிரி ஒவ்வொன்றும் வேற ப்ரெஷரா இருக்கலாம்
It
ஏதோ
can be
வேரியேஷன் இருக்கும்.
multimodal data, but for the simulation, they always store in a standard way.
ஓகே அது என்ன
Standard
ஸ்டாண்டர்ட்?
latitude, longitude, surfaceல different discrimination. அதுல ஸ்டோர் பண்ணிக்க வேண்டியது. It's stored as a 3D vector. அவ்வளவுதான்.
ஆனா அது என்னத்தை ஸ்டோர் பண்றாங்க அதுல? Is it an image or is
No,
it
it's just an array. It's a 3D array of numbers. அவ்வளவுதான். For example,
சரி.
if you look at temperature, நான் வந்து discretize பண்ணிட்டேன்.
Oh,
Latitude,
okay.
longitude,
Temperature
different
in
level.
every.
Yeah.
What is the temperature? Temperature
What is the
மட்டும்.
temperature at each point in the world and at different atmospheric levels? இந்த 3D
சரி,
globeல what is the temperature at each point ஒரு அரேவா ஸ்டோர் பண்ணிப்பேன். அவ்வளவுதான். அதை
So
நீங்க
வெறும்
வேணும்
டெம்பரேச்சர்
visualize பண்ணிக்கலாம்.
வெறும் டெம்பரேச்சர் மட்டும் தான் ஸ்டோர் பண்ணுவாங்களா இல்ல what else
Now there is
வேற
close
ஏதாவது?
to 500 fields actually.
ஓ,
Temperature, pressure, sea speed. We can look at some of the things. UV light.
fantastic. Okay.
What is your vegetation? Okay, there's so much to store.
But
Close to 600 fields are there.
fantastic. Okay.
So each are dependent on each other. So that's the thing. Actually, in the data is available from an
அதாவது
organization called ECMWF.
அனாலஜி டிரா பண்ணணும்னா நம்ம போட்டோ எடுக்கிறப்ப ஒரு வித் அண்ட் ஹைட் எடுத்தா இப்ப நம்ம இருக்க ஹெச்டி டிவில வந்து 2000x2000 ஒரு வித் அண்ட் ஹைட் அதுல 3 கலர் அவ்வளவுதான் 3 கலர் ஸ்டோர் பண்றோம். அதுவே வந்து எவ்வளவோ ஜிபி டேட்டா பர் செகண்டுக்கு. இது நீங்க சொல்றத கேட்டா கொஞ்சம் பயமா இருக்குது. 500 ஃபீல்டு டிஸ்கிரிட்டைஸ் பண்ணா ஓவர் த எர்த் every second withinன்றப்ப the amount of data which has to be stored will be like I don't know யூடியூப் அது இதுலலாம் வர கண்டென்ட்டோட அதிகமா இருக்கும் போல இருக்கு.
No, it is not more than that. But actually, this is a very interesting thing you asked. Actually, the data is too much. It's close to in exabytes range. It's not even petabyte, exabyte range.
Oh.
And once they want to do a data center.
Giga, petaவா?
Giga, tera, peta,
exa. Peta,
exa.
Oh, okay.
So the whole data is close to exabyte. Okay, one of the interesting happened is that they moved the data center from UK to Italy.
எதனால அது?
For some logistical reason, they have to move the data. Okay, the most efficient way they figured out is that put all the disk in a container and drive it to Italy. And the data we move it through cables with some recovery and redundancy, this will never happen. You have to wait for months. So they put all the disk in
நல்லா இருக்கு இல்ல?
It's really happened. This is a real story.
புரியுது. அதாவது when we say அதாவது ஹைப்பர் பேண்ட்வித் அது இதெல்லாம் பேசிட்டு ஆனா கடைசியில கண்டெய்னர்ல தூக்கிட்டு போறதே ஃபாஸ்ட்னு சொல்றப்ப அந்த சைஸ் ஆஃப் தி டேட்டா பார்த்தா
the size of data is huge. Actually there is in the இதுக்கான input data you just want to download part of it will take hours.
But if you are storing, okay, so
probably a lot of people who use AI for climate, they complain that downloading this data is the most difficult part. So this is okay. That's what I want to say. Mainly the data set exists. Somebody has, which somebody is not ECMWF, which is European Center for Medium Weather Forecast, and the center is an European funded center. That center has stored the data for the last 50 to 70 years in different resolutions, different vertical resolutions. All the 600 odd variable ella data, they have stored it for the last 60 to 70 years.
And do they have it for the whole world?
Yes. Yes.
Wow.
So
country அதெல்லாம் ஷேர் பண்ணிக்கறாங்க அப்ப
satellite available online. This data நீ கூட download பண்ணலாம். You can download it now. Okay. So this is the first thing they did, which is made this AI for climate thing possible. Okay, you have 60 to 70 years data. For example, அவங்க ரெசல்யூஷன் எல்லாம் மாத்தி இருந்தா கூட அவங்களே ஒரு மாதிரி மேப் பண்ணிப்பாங்க. நீ இந்த ரெசல்யூஷன் எனக்கு வேணும்னு கேட்டனா அவங்களே வந்து மேப் பண்ணி they will provide you the resolution. அந்த மாதிரி ஒரு சூப்பர் கேட்டிருக்காங்க, பண்ணிருக்காங்க ஆக்சுவலா அந்த சிஸ்டத்தை.
You should share the site detail இருந்ததுன்னா you should share.
I think it's called Copernicus Data Center. Let me just put it on the
Copernicus. Nice. The name நல்ல name.
Yes, this is website போனீங்கன்னா you will have all the data. Okay. This is the Copernicus service which provides all the data for climate change. There you can find the climate data store in which all the data is there. Okay. Fantastic. You just need to log in, get some, and then you can get என்ன term வேணும், என்ன data set வேணும். For example, you will say one temperature, time, ocean surface time series data வேணுமா, 1970s to 2100, derived from climate predictions. என்ன spatial coverage, Europa, global, temperature coverage, future, past, present, எந்த செக்டருக்கு டேட்டா வேணும், யார் இந்த டேட்டா ப்ரொவைட் பண்றாங்க. UMSAT is satellite, Copernicus is weather service.
இது எவ்வளவு சைஸ்? ஒரு டேட்டா எடுத்தா ரஃபா என்ன சைஸ்ல இருக்கும்? பண்ணிருக்கீங்களா? அதை எக்ஸ்பெரிமென்ட் பண்ணி
I have done it before, but I don't remember. But obviously, the problem is that a lot of people are downloading this data all the time.
So slow-ஆ இருக்கும்.
It will be slow. That is one of the main issue. They are talking about hosting this data in other things.
அங்க டேட்டா செட்ஸ்னு ஒரு tab இருக்கு, அது பாரு. அது சும்மா
டேட்டா சைஸ் எங்க இருக்கு?
மேல அதான் ப்ரொவைடர்ஸ் அப்ளிகேஷன், அந்த டேட்டா செட்ஸ் கிளிக் லெஃப்ட்
இந்த டேட்டா செட் தான் இருக்கு. ஃபார் எக்ஸாம்பிள் இந்த டேட்டா செட் பார்த்தோம்னா எவ்வளவு இருக்கு? I don't see a data surface hourly. See, hourly data இருக்கு. NetCDF is one of the format which is used.
hourly 1970 ல இருந்து 2100 வரைக்கும் hourlyனா யப்பா.
This is only for ocean surface level temperature. Ocean
whatever, but like
ocean surface wave time series அவ்வளவுதான், வேற எதுவும் கிடையாது. So this obviously this data is huge, and the data is available for all the variables across the earth at different resolution. So this is the input data for your climate science. Then I want to say first thing.
Fantastic.
Fantastic. So anyone who, for example, one of the model which was called Pangu weather model, this was developed by guys who doesn't know anything about climate science. Climate science na என்னன்னே தெரியாதவங்க simple time series data by deep learning transformer use பண்ணி they predicted what the next weather is going to be. And it is very good. It did a very good job.
யார், எந்த டீம் இது?
This is a team based by Huawei. I will go into, there are 3 papers. There are 3 main models currently available. One is developed by Google called Graphnet. One by NVIDIA called FourcastNet. Third is called Pangu by Huawei. And some
Pangu,
maybe
the name is
these Chinese names can be a bit different. Yeah. So these 3 models are actually beating the actual simulations. But there is a caveat, I'll come to it later. They are beating the actual operational weather forecast, which is amazing. Yeah.
அவங்களுக்கு எங்க இருந்து கம்ப்யூட்டர் கிடைக்குது அப்ப?
First one is Google.
Okay, ஆமா. Huawei.
Second one is NVIDIA. Third one is Huawei. As I said to you, they only analyze six variables. Okay. At a very small resolution, not all the variables. Once you blow up to everything in the model la vandu romba. So வந்து இப்ப நம்ம பார்த்தோம்னா இந்த மாதிரி டேட்டா இருக்கு. First important thing is the data is available. இந்த டேட்டா வச்சு obviously நீங்க ஒரு AI engineer, you can simply think of different ways. You can simply come up with a model which can predict the output. So இதுல வந்து 3 famous models இருக்கு. I will just go through it pretty quickly. People who are interested can look at it at their free time. First one is this model called Graphnet by Google people, Google and DeepMind, Graphcast.
Oh, Graphcast. Okay.
By Google DeepMind and Google Research.
Okay. Oh, they are attacking this now. Okay, nice. They like DeepMind is the team which is working on AlphaGo and protein folding, AlphaFold. அதெல்லாம்.
yes,
So
yes, exactly same.
so they are looking into this ன்றது okay, nice. It's a new information.
This is one of the main, climate science is one of the main fields, yeah. For example,
Correct,
they're
correct.
looking at only 5 variables: 2 meter temperature, 10 meter U wind component, V wind component, medium sea level pressure, total precipitation. As I said, there are a lot of variables, and they're looking only 5 surface variables, similarly 6 atmospheric variables, and similarly pressure levels. Okay, so let's go to the actual what type of network they're using.
Oh, transformers யூஸ் பண்றாங்க. ஓகே, இப்பதான் புரியுது.
Now
சொல்லு.
here they are using graph neural networks. There's usually an encoder, then they use a graph neural networks where the data needs to be passed across all the mesh across the whole globe, and then they use a decoder. They have different mesh வந்து இருக்கு பாத்தீங்களா, different mesh இருக்கு. Different mesh they simulate at different scales. Yes, very good. Scales பண்ணி கடைசில ஆவரேஜ் பண்ணிப்பாங்க. ensemble மாதிரி வச்சுக்கோங்களேன்.
இதுதான் நான் வந்து இமேஜ் வால்யூம்ல எல்லாம் பண்றது.
Yes. So it's nothing. This is existing method, and they use the input data.
Fantastic.
Okay, in the time series data you have an input and output data. Yeah, this is supervised learning now. And your input state is available, your output state is the next state. Since you have 30 years
past
of
information,
data,
past information and true value இருக்கு.
Yes, பண்ணிக்க வேண்டியதான். So this is not very difficult problem. This is all supervised learning. They are using graph neural networks. Next,
so graph neural networks இதுல டைம் சீரிஸ் இன்ஃபர்மேஷன் எவ்வளவு யூஸ் பண்றாங்கன்னு ஐடியா இருக்கா? அதாவது graph neural networks works across space, அதாவது XYZ ல வர்க் ஆகும். அது across time எப்படி யூட்டிலைஸ் பண்றாங்க?
Across time you predict இல்லையா? Across time is each prediction.
அதான், so
time is not predicted in the modelல time இல்ல actually.
மாடல்ல டைம் இல்லைன்னா அப்படின்னா எவ்வளவு ஒரு they will have a window இல்ல, லாஸ்ட் ஒரு 10 days இன்ஃபர்மேஷன் எடுத்து 11th day predict பண்ற அந்த மாதிரி ஏதா இருக்கும்.
They use last whole information and predict the next one day and the next one day. So how long they can predict? Actually, sometimes this prediction holds good for 10 days. As you go higher and higher, or model cutoff date பண்ணி model பண்ணது government, once you want to predict as much as possible, up to 10 days, it works very well. Even if a latest operational weather forecast can only predict up to 10 days, not more than that. Okay, next FourcastNet. It's also pretty much same, but let's go into directly to the
results.
No, I want to look at the actual network.
So architecture.
Same encoder and de-encoder. Okay, va?
Oh, they are using transformers அங்க.
இங்க transformers கிடையாது. Pangu is using transformers. They are using something called a Fourier neural operator.
Okay, சொல்லு.
Fourier transform பண்றாங்க.
இந்த டிரான்ஸ்ஃபார்மர்ல பொசிஷனல் என்கோடிங்னு ஒரு லேயர் இருக்கு தெரியுமா?
ஆமா.
ஃபர்ஸ்ட் லேயர் அதுதான் அந்த ஃபோரியர் நியூரல் ஆபரேட்டர்.
இருக்கலாம், அது டிரான்ஸ்ஃபார்மர் இருக்கலாம், பட் மை அண்டர்ஸ்டாண்டிங்
அதுக்கு மேல இருக்க மாதிரி தெரியல, பட் அந்த ஃபர்ஸ்ட் அது
the multi layer transformer architecture then utilize adaptive Fourier neural network. Maybe you're right, they are using 4 transformers but then using a Fourier neural operator as an embedding. So this is one of the other example. Mainly FFT is very costly, but they are using it. Actually கொஞ்சம் tricks எல்லாம் இருக்கு. They use in the model xk, then you predict xk plus 1, then you go to xk plus 2 with some loss.
கேக்க பாக்குறதுக்கு
okay,
long range short range அது மாதிரி இருக்கு. long term short term. LSTMs னு நம்ம டைம் சீரிஸ் prediction-ல வரும் முன்னாடி.
Yes, this is all time series data. Yeah, so those methods are also applied here. Very good, yeah.
Nice idea. நல்லா இருக்கே, பார்க்கணும்.
I have not read the whole paper, but I listened to some of the talks. It was very interesting. Next one I want to show is this Pangu model by the Huawei people.
என்ன பங்கு?
Again here பாத்தீங்கன்னா is a simple transformers. You have a patch embedding, then you just merge it and you do a transformers and then decode it back, and then you predict it for different time actually. Okay, and then you do some massaging.
It's an interesting architecture. So we found 3 architectures: graph networks,
Using
adaptive
an embedding which uses Fourier neural
Fourier
operator.
இது வந்து
And the second one is
pure transform.
simple. They don't the Pangu model. This one what we are looking at here. These guys don't even know the climate science. They just came up with this model based on just computer science. This has no knowledge of climate. They just said these are the variables. Let me embed them and then put it to a transformer and decode it back. That's it.
More like data set எடுத்து கேகல்ல நாங்க ப்ராப்ளம் சால்வ் பண்ற மாதிரி சால்வ் பண்ணிருக்காங்க.
Yes.
நல்லா இருக்கு இது கேட்கிறதுக்கு. ஆனா அது வந்து I'm surprised how again who are like global level of data set. Pangu weather. அதானா Pangu.
Okay. So I think currently the Pangu seems to work very well compared to FourcastNet and Graphnet.
When was this published roughly?
Published 2 months ago.
Wow.
Okay. But this work has been going for a long time. Okay, Nithilan, we will explore this in detail in the next video and see what are the advantages, how it performs very well, and also what are the problems in the next talk. Okay?
Cool. Sounds like a plan.
Yeah, thank you.